Hi guys, in this video I am going to talk about how to obtain expressions of full ladder by using a truth table. Right, in here we know the full ladder. When we consider the full ladder, we know the full ladder has three inputs, and it will give the sum as the output and as well the carry. That means the full ladder represents the addition of 3 bits. Addition of 3 bits because it has 3 inputs. Before considering the truth table of the full ladder, let me consider the 3-bit addition. In 3-bit addition, we know first of all, let me add 3 zeros. When we add these 3 zeros, the output is 1 0 1 0, and the carry bit also 1 0, no carry. And if we add 1 and 2 zeros, if we add 1 and 2 zeros, then the output is 1 and carry is 0 again. Then again, if we add 2 ones and 1 0, then the output is 0 and it will carry 1 bit. Then if we add 3 ones without any zeros, if we add 3 ones, then the output is 1 and it will carry another 1. This is the way how to add the 3 bits. Therefore, in this example, this column represents the sum and the next column it represents the carry out. Okay, now let me move to the truth table. In truth table, our inputs are A is an input and this B is an input and C is an input. These are our 3 inputs, A, B and C in. Our outputs are the sum and carry out. Right, let me go one by one quickly. We are inputting 3 zeros, 0, 0, 0. Then according to the above 3 bits, the sum becomes 0 and carry out become 0. Next one, 2 zeros input and 1 is there. Then this according to above, the sum become 1 and the no carry out. In the third one, again we have only 1 and we have 2 zeros. For inputs. Then the sum is again 1 and the output is carry out is 0. Sum is 1 and carry out is 0. In the next one, we have 2 ones. And 1 0. Then 2 ones means output is 0 and 1 according to the above 3-bit addition. Then sum is 0 and carry out is 1. Then again we have 2 zeros and only 1 1. Then sum is 1 and the output is 0. Next one, we have 2 ones, 1 0 as the input. Then the sum is 0 and it will carry 1 bit, 1. Then again there are 2 ones and 1 0. Then again sum is 0 and it will carry 1 bit. At last there are 3 ones as input. Then for the sum also there's a 1, and carry also carry bit, there's also a carry bit. This is the way how to represent these things by using a truth tables, 3-bit addition and the carry bit. Then we will divide this truth table into two separately, for the sum, for the sum and for the carry out separately, because now we are going to generate the SOP output. When we considering the SOP output, now let me move for the sum part, right? Where the outputs ones, we are considering this output ones, only this output ones. In summation we have only 4 outputs ones, right? Now we are going to write the equation. For the first one, A complement dot B complement C in, because C in is 1, therefore C in. For the next one, A complement, B is 1, therefore B, and C in complement. Then the third one, A, B complement and C complement. Then for the last one, all inputs are A, B and C in, because all the 3 inputs are 1s. This is the SOP output for the summation. Then let me go for the SOP output for carry out. For the carry out also have 4 outputs for 1s. We are considering only these ones because we are considering the SOP, sum of product. SOP means sum of product. Then for the first one, A complement, B, C in. Then for the second one, A, B complement, C in. Then for the third one, A, B, C in. And for the last, all 3 are theirs because all are 1. A, B, C in. Then the sum, the equation of the sum from the SOP output, we can represent it like this. Sum equal A bar B bar C in plus A bar B C in bar plus A bar C in bar plus A B C in. And as well, we can represent the carry out expression. A bar B C in plus A B bar C in plus A B C in bar plus A B C in. These are the sum of products expressions that we can obtain from these truth tables, separately for sum and separately for carry out. Remember, we have to take 2 expressions, separately for sum and separately for carry out. Then now we are going to simplify these expression. First of all, let us simplify this sum expression for the sum. Then expression for the sum is represented like this. Then in here, before simplifying this expression, we have to consider some important facts, right? For that, these are very important. In here important facts. First one, let me move for this one. A bar dot B plus B bar dot A. It represents this expression is equal to A XOR B. We need to remember this one. This expression is equal to A XOR B. As well, A bar dot B bar plus AB. This expression is equal to A XOR B complement. That means XNOR gate. It equal to XNOR gate. Complement of XOR gate. This expression is equal to complement of XOR gate. These two are the important facts. First of all, in here we have to group these. We have to group them. Let me consider this first one and this second one as a 1, and this one and this one as the second expression. We have to group them. Then in here, the common terms in the first one, in this one, the common in for the both are A bar and A bar are common. Let me take out this A bar and this A bar. In this second expression, this A and this A are common. Therefore, let me take this A out. Then we can represent this expression like this. A bar, then B bar C in plus B C in inside the bracket, and A bar A out, then B in C in plus B C in. Now look at the important facts. B bar C in plus B C in. It represents this first one. It represents this first important fact. Therefore, we can represent this B bar C in plus B C in by B XOR C in as well. Now for the second one, here see B bar C in bar plus B C in. It represents this second one. That means XOR complement or XNOR gate. Then we will represent these two by B XOR C in bar. Okay, next one. Now in here we have to think this B XOR C in as a 1, and in here also B XOR C in as a 1, and this A bar and A as another one. These are two different. Think like that. Then now look at the first important fact. Now in here A bar and A represent this A bar and A in this first important fact. Then this B XOR C in, it represent this B, and this B XOR C in, it represent this B bar. Then again for this wall we can represent what? We can represent this wall by XOR gate. That means A XOR B XOR C in. We can represent it like this. Then this is the way how to simplify this sum expression of the full ladder, sum output. Right? As well, next we can simplify the carry out expression. Then again for this carry out expression we have to consider this important fact, the similar one. A bar B plus B bar A is equal to A XOR B. Then again we have to split them into two. First two as a 1, and this third and fourth as another one. Then the common, again let me take the common from the first two outside. Then here C in is common, therefore let me take C in outside from this first two, and in here in third and fourth we can take A, B are common for both, therefore we can take A, B outside. Then we can represent it like this: C in dot A bar B plus A B bar plus A dot B, C in bar plus C in. Then in here, this is the important fact, then we can represent this one by using what? A XOR B. And here C in bar plus C in, that means what? According to the inverse law, it is equal to 1. This is equal to 1. This is equal to 1 according to the inverse law. Then we can simplify this one. C in A XOR B plus A dot B. This is the final output. Simplify expression of carry out. Then at last, the simplify expressions of the sum we can represent by A XOR B XOR C in, and carry out simplified expression is C in A XOR B plus A dot B. Thank you guys. Then in the next video, let me consider how to create the flip-flops. Thank you.